Hi, I'm Catherine Grantham, and this is my presentation on superconductors. So first, looking a little bit at the discovery, a scientist named Heike Kamerling Owens, my pronunciation I'm sure is poor, was doing helium liquefaction experiments, and in 1908 he was able to successfully liquefy helium. By 1911, he had discovered that the resistance in a mercury wire essentially disappeared when submerged in liquid helium at 4.2 Kelvin. And this is interesting because it was contradictory to some other theories at the time, which postulated that resistance would increase with a decrease in temperature rather than decline to zero. And in 1914, he won the Nobel Prize in Physics for his discovery and contribution to the field. So as Ons continues his experiments, he discovered that even a relatively weak magnetic field destroys the effect of supercooling on resistance. So while superconductivity was great in theory, it wasn't very applicable at the time. And it wasn't until 1955 that Georg Yantema, again, I'm sorry that I butchered this man's name, discovered that the use of niobium as wire actually would maintain superconductivity in the presence of a magnetic field, albeit a weak one, but it would maintain. And about 6 years later, in 1961, Kunzler, Buehler, Zhu, and Wernicke discovered that a compound of 3 parts niobium and 1 part tin could support a high density current in a magnetic field up to 8.8 Tesla, which is amazing. The issue with this alloy is that it was pretty brittle and so wasn't very usable. So the next year, another pair, Berlincourt and Haig, found that niobium with titanium alloys could be used up to 10 Teslas. This compound's a little less superconductive, but because it's less brittle, it's become the alloy of choice in most supermagnetic applications. So moving into usage, some modern applications of superconductors include magnetic resonance imaging, or MRI, as well as the magnetic confinement within fusion reactors, and the push-pull superconductive electromagnets used to power maglev high-speed trains. In recent news, in 2015, a class of high-temperature superconductors was discovered, and this began to open the door for more potential applications of superconduction. And just a year ago, in October of 2020, news broke of a superconductive material that maintains its properties up to a temperature of 15 degrees Celsius or 59 degrees Fahrenheit, becoming the first room temp superconductor, which is super exciting. However, that mixture of carbon, hydrogen, and sulfur only maintains this at an incredibly high pressure. We're talking like center of the earth level pressure that was induced in the experiment by placing the mixture between 2 diamonds. So for now, application of this alloy remains incredibly impractical. And finally, my use for superconductors. While high temp superconductivity remains impractical, some research points to future potential for high temperature usage in magnetoencephalography, among many other medical applications. But this particular one would be groundbreaking as it would act as a method for non-invasive testing and diagnosis of brain activity, something I'm passionate about as a survivor of a brain tumor. Anyway, thanks for listening to my presentation, and I hope your day goes well.